Today's lesson is on 3.4, graphing linear equations in standard form. There's a couple important vocabulary words today. First one, horizontal line, is a line that has a slope of 0. The equation is just y equals a number, where that number is actually going to be the y-intercept, and it's constant. It looks like a flat, straight line on a graph. Next one, we have a vertical line. A vertical line has an undefined slope, or no slope. The equation for that line is x equals the number. That number is going to be the x-intercept. It's also going to be the constant. This looks like a straight up and down line on a graph. A couple more important vocabs for today. Slope is rise over run, or the rate of change. We're going to learn more about this in the 3.5 lesson. And then rise is the change in y, and run is the change in x. So when we're counting slope, we're going to count the distance up and then the distance over between 2 points. All right, so remember in the vocab we said when y equals a number, that's a horizontal line. So that number is also going to be the y-intercept. So when I graph y equals 4, I'm going to find the point on the y-axis where y equals 4, and then the function is just a straight line through that point. All right, and then on the vocab in the page before this, when x equals a number, that's a vertical line. So to graph x equals -2, I'm going to find the x-intercept, -2, and then draw a straight up and down vertical line through that point. And the slope of the first line would be 0, and the slope of the line in part B would be undefined. All right, the first form of linear equations we're going to work with is standard form, which is written as a number times x plus a number times y equals a number. Now, the advantage of this form is that it's the easiest to find the x and y intercepts with. So, what are the x and y intercepts? The x-intercept is the x-coordinate where the graph crosses the x-axis, so that's this point here in the picture. And then the y-intercept is the y-coordinate where the graph crosses the y-axis. That's this point here. When we're finding the x and y intercepts in standard form, we do still have to solve for x or y. So to find the x-intercept, we plug in 0 for y and solve for x, because notice in the x-intercept, y is 0. So if we plug in 0 for y, we'll find the a in that ordered pair, or the value for x in the x-intercept. And then likewise, when we find the y-intercept, we plug in 0 for x and solve for y, because notice 0 is the x value of the y-intercept. All right, so example 2 looks a lot like your homework with this lesson. We're going to use the intercepts to graph each equation. So the first thing we have to do is find the intercepts. Remember, when we're finding the x-intercept, we plug in 0 for the other variable. So to find the x-intercept, we're going to plug in 0 for y. So I'm going to rewrite the equation 3x plus 4 times 0 equals 12. And now I know anything times 0 is 0, so this section just cancels out. And then I have 3x equals 12. Solve for x, divide both sides by 3, and x equals 4. So the x-intercept is 4, 0. And then we're going to solve for the y-intercept. So we're going to plug in 0 for x. So I'm going to rewrite the equation 3 times 0 plus 4y equals 12. 3, 0 goes away. And then I have 4y equals 12. Solve for y, divide both sides by 4, and I get y equals 3. So the y-intercept is 0, 3. Now I have 2 points that I know are on this graph, so I can go to the graph and plot 4, 0 and 0, 3. And then all I have to do is connect the dots to graph that equation. All right, that's our equation for part A. Now I encourage you to pause the video and see if you can do part B by yourself, and then see if you got it right. I'm going to go ahead and solve part B. So for the x-intercept, we plug in 0 for y, so I have x plus 3 times 0 equals negative 9. That cancels out, so I just have x equals negative 9. The x-intercept is negative 9, 0. And then the y-intercept, we plug in 0 for x. So I have 3y equals negative 9, solve for y, divide both sides by 3, and I get y equals negative 3. Or the y-intercept is 0, negative 3. So then we're going to plot both of these points on the graph. So I have negative 9, 0, and 0, negative 3. And then connect the dots. And that is the graph of x plus 3y equals negative 9. All right, example 3 is some problem solving. You are planning an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 6 people, large tables seat 10 people. The equation 6x plus 10y equals 180 models the situation. So x is the small tables, y is the large tables. We're going to graph the equation and interpret the intercepts. So first we're going to find the intercepts. I'm going to set this up the same way we set up example 2. So x-intercept, we're going to plug in 0 for y. So I have 6x, and I know 10 times 0 is just going to cancel out, so I'm just going to say 6x equals 180. And then x equals 30. And then the y-intercept, 6x will cancel out, so I have 10y equals 180. And y equals 18. So now I can plot both the points 30, 0, and 0, 18. All right, so I plotted those 2 points and set up the graph where both axes count by 5. So then we're supposed to interpret these intercepts. So what does it mean that when x equals 30, y equals 0, and when x equals 0, y equals 18? Well, x represents the number of small tables, and y represents the number of large tables. So when you order 30 small tables, you have 0 large tables. When you order 0 small tables, you have 30 large tables. So any point on that line is going to seat exactly 180 people. If you choose a point somewhere over here, you're not going to seat enough people. And if you choose a point somewhere over here, you're going to have too much seating. So the ideal number of tables would be some point on that line where both are whole numbers. And that's the maximum number of small tables and the maximum number of large tables you could order. So find 4 possible solutions for this problem. Well, if we're looking at the line, we're looking for whole number solutions. And I know it's kind of hard to tell since we counted by 5s on the axis, but those whole number solutions are going to be at 5, 10, 15, 20, 25, so on. All right, so one of our solutions is at 5, 15. I could have 5 small tables or 30 people seated at small tables and 15 large tables. I could have 10 small tables and 12 large tables. I could have 15 small tables and 9 large tables. Or I could have 20 small tables and 6 large tables. So if you plug in those x values, you will get those matching y values. There are more solutions, but it said 4. Here's 4 possible solutions. All right, so some summary questions to wrap up today's lesson. When comparing the equations, what is the difference between a horizontal and a vertical line? Horizontal are flat and vertical are straight up and down. The horizontal lines have a slope of 0. Vertical lines have an undefined slope. All right, where do you find the x and y intercepts on a graph? Those were important vocabulary words for today. The x-intercept is the point where the graph crosses the x-axis, and the y-intercept is the point where it crosses the y-axis. How do you use intercepts to graph linear equations? If the equation is in standard form, you can plug in 0 for x or y to find the other intercept, plot the intercepts, and you can connect the dots to graph the equation. How do you use standard form to graph a linear function? We use that to answer the last question. If I'm finding the y-intercept, plug in 0 for x. If I'm finding the x-intercept, plug in 0 for y. Graph the intercepts, connect the dots.